Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Ethan Mueller.
Hello, and welcome back to another episode of Tech to Tech. Today we're going to be discussing cleaning no clean paste with a water-only cleaning process. I'll give you a spoiler. This is not a recommended way to clean your no clean paste. If you had asked me previously, I would have told you there's 3 different families of paste. However, I recently learned there's 2. There's water-soluble paste, and there's no clean paste, and that rosin RMA falls under the no clean category. Hearing this, one might assume that cleaning is the most important part of the entire SMT process. You won't get any argument from me. However, in all fairness, there's a lot of other stuff as well. But no clean paste, why do we call it this? Why are we naming our paste no clean paste? And the whole reason that this family of pastes came to market was because the solder people decided that they wanted to eliminate that cleaning process, right? That no value add, costly cleaning process. We wanted to come up with a product that, a solder paste that we would be able to use and not have to clean. And we were going to do this by having a product that has minimal residues, benign residues, and those residues are encapsulated by some sort of layer, which is different, and it all depends on the specific paste that you're using. And so what I'll say about all this is I've heard more than one solder paste person say, everybody cleans, no cleans. And they were probably saying this to appease me, which I think to be the case because I know that not everyone cleans their no cleans. But my point is, it begs the question of, should I clean my no clean or should I not clean my no clean? And it really boils down your process, your customer, your builds. And so again, we're going to compare and contrast whether or not we should clean or we don't need to clean. And no clean, not today. We want to reduce our overall build time, increase our throughput. We want to reduce our process costs. We don't need that expensive washer. We don't need to buy chemical. We don't need to consume water. We don't need to deal with the wastewater that our cleaning process generates. And again, those residues that are part of the no clean paste package, they're minimal or they're benign residues. Or the question is going to be, clean, no cleans? Yeah, we probably should because we're in a high reliability industry. We build boards that people's lives depend on or expensive equipment depends on it. So we want to do everything we can to improve our electrical reliability, eliminate those leakage currents, prevent premature failures, do everything we can to eliminate dendritic growth, which is the main cause of shorts. And if we're conformal coating, we want to look at cleaning to improve our adhesion and to improve the longevity of our coating in the field. Maybe it boils down to how we inspect and test our boards. You got a cleaner board, it's easier to look at. But another thing is the electrical testing. You'll hear this a lot regarding solder paste, whether it's probable or not. A lot of the no clean paste are not probable. And so what that means is that layer that it's leaving behind, you can't do electrical testing to. So if you have to do electrical testing to your board, you might have to remove that residue to do your electrical testing. And my favorite point is it makes your board aesthetically pleasing. You're going to like the way your boards look. Your customer's going to like the way your boards look. And that's going to do everything to help you drive your business at the end of the day. Okay, so we've asked whether we should or should not clean, and we've decided that we're going to clean. But we've come up with a good idea. We're going to clean, but we're going to clean with water only. And this way, we're going to save on cost, right? We don't have to buy any chemical. We're going to have an easier time disposing of our waste. It's going to simplify our process. We don't have to monitor our chemical concentration to be at 13 to 15%. We don't have to have chemical product on our floor that if we run out of, now we're at a bottleneck in our production because our production is validated to run a chemical. And so our production line's running smoothly, costs are down, we have a happy customer at the end of the day. Not so fast. don't forget about that encapsulation layer. When it comes to no clean paste, there's that encapsulation layer. And the problem with cleaning with water only is that it's not fully equipped to go and remove all the residues that are there. And what happens is the mechanical energy from the process actually deteriorates that encapsulation layer, which results in a partially cleaned board, which now your residues have been freed to be mobile. And what does that lead to? Dendritic growth. So we have actually done ourselves a disservice by cleaning with water only. So we've added a cost, and now we've reduced the reliability of our board in the field by weakening that encapsulation layer to allow for a greater potential of dendritic growth. So, again, we can clean. We were talking about cleaning without water or without chemical. Now let's look at cleaning with chemical. In most situations, you can find a chemical that will solubilize that encapsulation layer and remove all those contaminants that are encapsulated. Now, this isn't the case every time. There's some pastes out there that are really, really, really tough to clean. But in most situations, you're going to find a chemistry that will fully clean your no clean paste, and you can dial in a process to make it clean really good. In addition, you're going to what I like to call cast a wider net. Not only are you going to be able to clean those pastes, those flux residues away, you're also going to do a better job and be more well equipped to remove other manufacturing debris that are maybe from a manufacturing process or from your supplier or from your operators. Again, we're more well equipped to remove all those residues from our board. And then this is a very important point, is chemical additives reduce the surface tension of the liquid that you're using, right? Water alone makes a big droplet. You add chemical in there, you get a smaller droplet, which means that you can get into tighter spaces to clean in those tighter spaces, which is, of course, very important in electronics when we're dealing with all these low standoff components and whatnot. So again, when we're looking at cleaning or not cleaning our no clean paste, there's a few things that we need to compare and contrast. The consideration or we should never compare and contrast water only washing versus chemical only washing. It should only be, should I clean with a chemical or should I not clean at all? There's no in between. And so some things that we're going to ask ourselves is, what is the reliability of our build? If it's what we deem critical clean in the industry, it's going into a body or a really expensive piece of equipment relies on it, we probably want to clean. If we're doing conformal coating, we want to consider that, or what can we do to improve our conformal coating to better take and to also last longer in the field. And then finally, what type of testing are we doing? Are we doing some sort of electrical testing to our board? Can we probe our connections without actually cleaning, or do we need to clean to achieve that testing? And so, in conclusion, when we're talking about cleaning no clean pastes, we either want to skip cleaning entirely or we want to go all in with a chemical additives. Water alone is not sufficient to clean no cleans. Again, you're doing yourself a disservice. You're adding cost to your process. Chemical, you can find yourself a chemical that works well to clean your paste and get you to where you need to be. Optimizing a process, whether we're talking about no clean paste or not, you should always look to optimize your process. But really what we want to do is we want to do some testing to make sure that we are cleaning as well as we need to. We want to get sufficient cleanliness, and there's a lot of different ways that we can quantitate that. Moving on to the frequently asked questions. What should I do if my machine is set up for water only and I am exploring a new no clean paste? In this situation, I would recommend that you work with your equipment manufacturer. There's a lot of situations where a piece of equipment can be retrofitted to accept chemistry. In most scenarios, you don't want to add chemistry. There's some workarounds where you can add chemical into a water only. And this is typically not the way you want to do it because you're going to use a lot of chemistry. The way those machines are set up is usually a lot of stuff goes to drain. If you try to add chemical into that, your chemical is going to go along with it. And so again, a lot of equipment can be retrofitted, or you can do some sort of add-on stage. There's a lot of companies out there that offer that sort of thing, but you don't want to clean your no cleans with water only, and you don't want to, put chemistry into a machine that's set up for water only. You want to either retrofit or find some other alternative. Can IC crack the encapsulation layer? So in this question, let's assume that we've built a no clean board. We didn't clean it. We do an IC. Is that problematic? Yeah, absolutely can crack that encapsulation layer. If you want to use this board, you maybe want to consider cleaning it, or maybe you're worried that water or something, you got your boards wet or contaminated them. You can always clean that paste later. There is some discussion about paste becoming more challenging to clean with time. That's a different conversation. But you can always clean a board before conformal coating if you feel the need to. Am I able to clean water-soluble flux with water only? Yes, all of the residues in water-soluble flux are water-soluble and therefore can be cleaned with just water. However, there is some things to consider about chemistry that may make it somewhat attractive. The first being, what about all those other soils? What about the soils from your supplier or from your upstream manufacturing process? Those types of things. Chemistry helps cast that wider net so that you're more likely to be able to clean those things. The second consideration is you can clean faster when you have a chemical additive. And so maybe, that's something that makes it more attractive to you specifically. And finally, those low standoff components. Water makes a big droplet. Chemistry makes a small droplet. And so we can get under those low standoff components and do a better job of cleaning. And so again, these are things that you, as the process engineer or whomever, these are the things that you should be looking at and weighing to decide whether or not you want to use a chemistry in your water soluble cleaning process. Just say this one more time. When it comes to no clean, you absolutely want to use a chemical or you don't want to clean at all. There is no in between. And with that, I'll turn it back over to William, and thank you everyone for joining today. Hope you have a great day. Take care. Bye.
Thanks, Ethan. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.